Classes and objects are fundamental to object-oriented programming, OOP. Here's why they are important. 1. Encapsulation. Classes encapsulate data and methods that operate on that data, providing a clear structure. This hides the internal state of objects and only exposes necessary parts, making the code more modular and easier to manage. 2. Reusability. Once a class is defined, it can be reused to create multiple objects. This avoids code duplication and promotes the dry, don't repeat yourself, principle. 3. Inheritance. Classes can inherit properties and methods from other classes, enabling the creation of hierarchical relationships. This helps in code reusability and extending functionalities without modifying existing code. 4. Polymorphism allows objects of different classes to be treated as objects of a common superclass. This enables writing more flexible and reusable code. Dynamism in Python. Python's dynamic nature allows for more flexible and less verbose code. Here's why it's beneficial. 1. Flexibility. You can write more generic functions that operate on different types of objects, reducing the need for multiple similar functions. 2. Ease of use. It's easier to prototype and test code because you don't need to define strict types for every variable and method. 3. Readability. Often, less boilerplate code means more readable code. Code organization and maintenance. While dynamic typing can lead to messy code if not managed properly, good coding practices can mitigate these issues. Clear naming conventions. Use meaningful names for variables, functions, and classes to make the code self-explanatory. Documentation. Write docstrings and comments to explain the purpose of classes and methods. Testing. Use unit tests to ensure that your code works as expected with different types of inputs. Type annotations. Python supports optional type hints, which can help with code readability and maintenance without losing the benefits of dynamic typing. Unit testing is a software testing technique where individual units or components of a software are tested in isolation. The goal of unit testing is to validate that each unit of the software performs as expected. In Python, unit tests are typically written using the unitest module, which is part of the Python standard library. Basic concepts. Unit, the smallest testable part of an application, such as a function, method, or class. Test case, a set of conditions under which a tester will determine whether an application or software system is working correctly. Test suite, a collection of test cases that are intended to be executed together. Test runner, a component that orchestrates the execution of tests and provides the outcomes to the user. Benefits of unit testing. Early detection of bugs. Errors can be found early in the development cycle. Simplifies integration. Testing individual components makes integration easier. Documentation. Tests act as a form of documentation, showing how components are expected to behave. Refactoring support ensures that code changes do not introduce new bugs. The unitest module is imported to provide the testing framework. Two functions, add and subtract, are defined to perform basic arithmetic operations. A test case class, test math functions, is defined with two test methods, test_add and test_subtract. Each test method uses self-assert equal to check if the actual output of the function matches the expected output. The unitest main function is called to execute the tests when the script is run directly. Type hints in Python are a feature that allows you to specify the expected types of variables, function arguments, and return values. They were introduced in Python 3.5 through PEP 484 and have since become an integral part of writing clear, maintainable, and self-documenting code. Type hints are used purely for static type checking and do not enforce type constraints at runtime. However, they can be used by various tools and IDEs to provide better code analysis, autocompletion, and error detection. Type hints are essentially annotations. For example, integer, int. Return integer, int. Float, str union. Static type checkers like MWipeY are tools that analyze your Python code to ensure that the type annotations you have provided are consistent and correct. They don't run your code, but instead examine the type hints to catch potential type errors before runtime. Benefits of using MWipeY: early detection of errors, catch type errors before running the code. Improved code quality, ensures that type hints are used consistently and correctly. Documentation, provides clear documentation on what types are expected, which is useful for other developers.